So welcome you all to this video lecture. So here in this video lecture, we are going to see the continue to the topic we have discussed in the previous video lecture, interrupt. So in previous video lecture, we have a clear idea regarding to understand what is mean by an IRQ interrupt request, interrupt service routine ISR, and acknowledgement terms and interrupt latency. So now here we are going to discuss with respect to that continuity. If suppose what it happens when more number of devices requests the processor at the same time means. So how it will going to get handle that? How the priority is going to give to that devices prioritization. So interrupt handling and the prioritization is going to be discussed over here. So the things is here we first need to have the thing is multiple interrupt request. So when several IO devices, which means that are connected to a processor, if a processor there, so multiple IO devices, several IO devices are connected over there. So those connected devices may generate an interrupt request whenever it requires the services. So if suppose if only your devices generates an interrupt request means the processor can directly services the request provided devices and it will complete the processor. If suppose at a simultaneous time the multiple devices will generate the request means the processor need to give some logic, which means that we need to determine which program need to get, which means that which request I need to give high priority. So that decision making mechanism is called as a priority arbitrations. So if multiple devices, if for an example a device 1 d1 d2 and d3 is there means it will generate a IRQ interrupt request. So those requests will send where means those uh, to interrupt controller. So in that interrupt controller it will send to the CPU. So the thing is the interrupt controller or a priority logic will receives what means the request from the devices and determines which request I need to should represents the processor for services. So the thing here, the priority why we need is means we can't process we why cannot the processor simply selects any interrupt because all the interrupts may not have the same importance or an urgency. If for an example, if the processor is get, which means that a device is get connected to multiple devices such as a secondary memory device or any Arduino boards or to that of output devices it connected means it need to justify which thing I need to get prioritized things as. So some devices may require some immediate services while the other can wait for some short period and it can perform over there. So therefore the system need to get assigned the different priority levels to the different interrupt sources only. So after do that, the high priority interrupt is get selected from before to that of low priority things is when both requests are pending. So just for an example, it will do the process like high priority one. So after that high priority, the timer is get scheduled over there. So through that, the communication will be shared. So then storage and the lower priority signal get prioritized. So thing is the exact priority depends on the processor architecture only and processor architecture whereas system design also. So the important idea is that the priority determines is what means the order in which the pending interrupt requests are service. So the next is the priority arbitration. So for an example, in the priority arbitrations, uh, first I say what it is. The priority arbitration is nothing that the process of selecting one request from the multiple simultaneous request, which means that how to say means the priority arbitration is nothing that the process of selecting one request from multiple simultaneous requests according to that of what means a priority predefined priority schemes. So in that the arbitration logic examines what means the interrupt request and determine which one I should need to allow to proceed for that ad hoc time. So after that the selected interrupt services, the another one will go for the pending state. After that completion, the pending interrupt can be get selected. So if suppose an example, the multiple IRQ get generated. So multiple MIRQ, multiple IRQ get generated means it will send us to priority logic. So after that, select the high priority one. So after that, the CPU services the interrupt. So next the pending IRQ. So we can say that therefore the priority arbitration answers what? One simple questions: which interrupt should the processor service first? So the fixed priority is nothing that it is a mechanism. So which means one simple priority mechanism is called as a fixed priority. In that fixed priority arbitration, each interrupt shows us has what means a permanently assigned priority things is. So one device always has a higher priority thing, the another devices has the next priority one, and so on. So if the multiple requests arise simultaneously means what will we do means the higher priority request is get selected. So if for an example I have the devices number from device A to device D, device A, device B, device C, and device D. So the prioritization this device A has a priority 1, P2, priority 2, priority 3, and priority 4. So if A to C request simultaneously means A is selected because A has a high priority 1. So B and D request simultaneously will process, after that B is selected. So the fixed priority is simple to get implement, but it has some disadvantages are there. So such as the starvations. The term we are going to say that the problem disadvantage is called as starvation. So a low priority device may continuously need to wait for if the high priority devices generate interrupt frequently. If suppose a high priority one unhackily provided a service request means the least priority devices D need to wait for that. After that, the only it will do the process. So here that lagging time, so waiting time is called as a starvations. So therefore, while fixed priority provides us what a simple unpredictable mechanism. So therefore, the system designer have to consider whether the lower priority devices can receive sufficient services. So simply we can say that the higher priority devices will censor some IRQ interrupt request. So CPU automatically keeps servicing over to that. So low priority devices that IRQ need to wait till that the higher priority device get completed. So the priority arbitration must be designed carefully. So the next is the nested interrupt. So the nested interrupts and the vectored interrupt is nothing that nested interrupt nesting means suppose a processor is there is already executing some interrupt services routine for the lower priority interrupt. So and then here I just need a higher priority request arises means the processor architecture permits us nested interrupts so that the processor can be temporarily suspended the current interrupt service routine ISR and services the what the higher priority interrupt. So if for an example a main program is there, it will go for the low priority IRQ. So then it proceeds as process those low priority ISR. So after that high priority interrupt request came means that higher priority interrupt service routine will follow to that. After that only it will return back to the top low priority ISR and will return back to the top main program. So thing is that the processor here this provides us what the faster responses to the important event, but it also makes us some interrupt handling is we get more complex thing because the processor has to be preserve the additional state. So that is going to discussed in the terms as I enable and I pending. So this is the terms as where we have some process. So the next thing is that we need have to clear over there in the upcoming topics regarding to the top vectored interrupts and the terms as followingly.